This is a question from Kyle, asking how detailed the images would be if the Hubble telescope were pointed at Earth. This is a fairly common question that Hubble operators receive quite often, and there is an answer on the FAQ page. The problem is not that some think the Earth is too bright, as noted by Phil Platt from Bad Astronomy. The Hubble telescope periodically turns towards Earth to calibrate one of its instruments. The main problem is that Hubble is too slow. Let's figure it out. Let's imagine we want to take a photo of an ordinary table. A photon from the table must travel through the Earth's atmosphere, which can create problems for ground telescopes, but is not as critical for space ones. The matter lies in geometry. If distortion occurs closer to the source, it affects the image less severely. The first small problem we will encounter is the resolution. Hubble is the best telescope for observations in the visible spectrum, but its resolution has its limits. Pluto, located in the Kuiper Belt, lies at these boundaries. Before the New Horizons flyby past Pluto, the best photos we had were taken by Hubble, and they were quite blurry. For Hubble, this planet looked like a mysterious spot. Considering Hubble's resolution and the distance to the table, it would look like this. I assume the table is under light from the window or outside. However, the main problem is movement. Hubble moves across the Earth's surface at a speed of over 7 kilometers per second, meaning that from its perspective, the table rushes by at the same speed. Any reasonable exposure time, even with perfect resolution, will be completely blurred in the direction of motion. This is the same problem as when driving on the highway and trying to photograph the ground under the car. If we combine two effects, resolution and movement, we get a result that looks like this. It's not very good. Can we rotate Hubble to track the surface and eliminate blur? In fact, Hubble regularly rotates to track targets during its orbit, but usually these are astronomical objects that are far away. Automatic tracking algorithms can handle objects no closer than 10 times the distance from the moon. When astronomers want to use Hubble for photos of the moon, they need to send manual commands to turn the telescope and activate the camera during the maneuver. It doesn't work very well. The resulting photographs are better than what the naked eye can see, but do not meet the high standards of Hubble. Here is our table with an image degraded by a similar amount. Unfortunately, relative to its size, our table moves across the telescope's field of view much faster than the moon. Strangely, the table doesn't move that quickly. At least the angle to the table doesn't change. To monitor the Earth's surface, Hubble would need to rotate at less than 1 degree per second, or about a tenth of a rotation per minute. But Hubble is too slow. It wasn't built for tracking the surface. The maximum rotation speed of the telescope is only a few degrees per minute, about as fast as the minute hand of a clock, and even such speeds are sufficient for its gyroscopes to cause vibrations that degrade image quality. Clearly, we need our own target control system. The moment of inertia of Hubble is similar to the moment of inertia of a small carousel, which is not much in absolute terms. With our user system, Hubble could monitor the surface and obtain photographs close to optimal quality, meaning that while Hubble couldn't read the text over your shoulder, it could observe you rolling in your office chair. But this is not just a hypothetical situation. Many technologies of military spy satellites are considered similar to those used in Hubble. Thus, directing a Hubble-type telescope at the Earth's surface is not only possible, but it is actually what the US government is doing.